Okay. Here is arc sine, or here is lesson 39, number 22. I think that's one of yours too, Cameron. So arc sine means find the angle that goes with this answer, basically. Does that help if I say it that way?
What?
Arc sine, this problem means find the angle that goes with that answer.
That would be helpful.
I don't know if that helps you to think of it. Arc sine, when it has a capital A, you guys know that arc sine means inverse sine? So if it has a capital A, then usually we try to use quadrant 1 and 4. And actually arc sine, we can use quadrant 1 and 4. So it's going to be in one of these two quadrants. So I look at, it's negative. So can it be in that quadrant if it's a negative? It can't be in this quadrant because it's negative. It has to be down here. So that means I'm going to draw a triangle. And I'm going to ask myself, what degree must that be? What is that? If I ended up with root 2 over 2. Oh, and I can even, if I don't already know, like I already know, I think you guys might have an idea. Yeah, he's like 45, isn't it 45? So you might recognize that because that's just something that comes up all the time. If you don't recognize it, you can say, well, sine is the opposite over hypotenuse. So you can grab this as the opposite, and that's the hypotenuse. So you can just grab it and go, opposite, hey. But actually, no, it's trickier that way because this thing probably looked like this. It probably looked like that, and then somebody walked up to it and said, hey, let's get our denominator rationalized. And that's how it turned into root 2 over 2.
Yeah.
So that is actually really tricky. Because if you just walk up to it and say, oh, well, opposite over hypotenuse, you'd get your root 2 over here, and then you'd have a 2 there, and that, you know, that's not right. So I guess, I don't know how to tell you good luck on that. But does that look familiar to anybody? Like, aren't you used to seeing negative root 2 or root 2 over 2? So you should kind of just be able to look at it and go, well, that's what I always get every time I work with a 45, 45, 90 triangle.
Why couldn't it be in the tangent quadrant?
Because thank you for asking that. Because this is a capital A. Now, if that were a lowercase a, then it could be in all 4 quadrants. Since it's a capital A, it can only be in these 2 quadrants. I don't know if I know I missed that the first time I taught out of this book too, but no, really, because they told us in lesson, well, I'd have to look it up in my little lesson correlation sheet. Whatever lesson when they told us about arc sine, it said that there is a customary procedure to this. They have restricted the domain so that this is a function. And so we always restrict the domain to 2 quadrants. So for arc sine, the quadrants are 1. You just have to memorize it. It's all the mathematicians got together and they decided that we're going to use these 2 quadrants. Right? Because we want to use this quadrant because this is the one where everything's positive. And then you want to use another quadrant where you can get a negative value. So I can't use this quadrant because then I'd have 2 positive values, right? I'm trying to reduce the number of quadrants I'm allowed to work in. So I want to use these 2. And for tangent, for capital arctangent, I'm going to also use these 2 quadrants, right? Because I can get a positive thing here and a negative here. But for cosine, I can't, it doesn't work. So I have to use quadrant 1 and quadrant 2 for cosine. Sorry if you didn't catch that the first time around. Is that ridiculous? Well, otherwise, you know what would be really ridiculous? Is if they asked me for, why don't you give me all the angles that give me negative root 2 over 2? Well, then I'd be going around, I'd be like, oh, here's one, here's one, here's one, here's one, here's one, here's one, here. Like, you know what I mean? That we have to kind of restrict our answer. Otherwise, you have to write plus pi, 2 pi k or something on it. So, yeah. We'll end that now.